Hello and welcome to our webinar with Grundfos. I'll just play this video to get started.
Empowering the people who power our world. Since 1977, the Association of Energy Engineers has been leading the global energy community towards a clean and sustainable future.
Founded by Al Tuman, AEE emerged during a critical time when the world grappled with the oil crisis. Today, we're a global network of over 17,000 members and 32,000 certified professionals in over 125 countries, dedicated to implementing projects that improve energy efficiency, address climate change, and drive economic growth. AEE is a nonprofit organization dedicated to serving our members and other industry professionals by providing them with a framework where they can network, grow, and helping them stay abreast of the latest industry trends and empowering them to maintain a competitive edge through training and professional certifications. AEE developed the energy management profession. Our Certified Energy Manager certification is available in 10 languages and now has over 18,000 CEMs throughout the world. We also have certifications in energy auditing, building commissioning, sustainable development, renewable energy, carbon reduction, and a wide range of other specialized fields.
As we drive growth, innovation, and excellence across the industry, it's crucial that we empower all talented professionals to contribute. That's where CWEL, the Council on Women in Energy and Environmental Leadership, comes into play.
As a division of AEE, we are focused on supporting mentorship, networking, and scholarships for women.
The technical sessions were amazing.
The conference and expo is a great reflection of where we are at the industry. A lot of the exhibitors and content here is very current and very relevant, so it's a great way to come and get current with the industry.
What sets AEE apart is our commitment to driving change. We are a global family focused on putting people first and making the world better for current and future generations. The clean energy transition is happening now, so join us and be part of a community dedicated to this clean energy future.
Whether you're looking to advance your career, expand your network, or contribute to global climate goals, the Association of Energy Engineers is with you every step of the way. Together, we can shape the future of energy. Join us today.
So the Association of Energy Engineers is a hub for energy professionals worldwide. It's a global organization and it's dedicated to being at the forefront of energy innovation. The AEGCH chapter supports energy professionals by promoting best practices in energy management, supporting professional certifications like the one that you saw in the video before, and creating a strong local network of energy and sustainable professionals. We advance decarbonization, energy efficiency, and ESG goals in Ontario and Canada. So just to give you an overview of some of the events that we have on this month, we had an event last week at a technical tour at the Queen's Quay in the middle of Toronto. We also have this webinar and then an event on Friday, and then finally another webinar at the end of the month with Carbon Cap. So the event on Wednesday last week was part of our technical tours. So you got to go around the City Waterfront building, and keep an eye out on our website for more technical tours. This was organized with the City of Toronto and Ecosystem. On Friday, we have a data center event held at St. Clair Avenue West from 9 a.m. to 11 a.m. on Friday. This is in collaboration with CWEEL, Council on Women in Energy and Environmental Leadership. And on the 30th of July, we've got another webinar at 10 to 11 a.m. And please note that obviously this one's at lunch at 12, but the one on Thursday, the 30th of July, is at 10 to 11. So you'll hear from one of our platinum sponsors, Carbon Cap. So just a quick overview of our sponsors that we have. We have platinum sponsors Inspire, Carbon Cap, Edgecombe, Enbridge, Armstrong and Ambient. Gold sponsor Honeywell Forge and Grundfos, who's hosting the webinar today, and our silver sponsors Aladico, Kilmer, ENS, and Mitsubishi Electric. So Thank you for taking the time out for your lunch today. This is the 9th of our Coffee and Conservation series webinars with Grundfos. And I'd like to take a moment to introduce the two speakers that we have today coming from Grundfos. So we have Nitesh Dagur, who's a senior aftermarket sales specialist from Grundfos. She is focused on advanced energy efficiency and decarbonization in the built environment. She leads initiatives that optimize HVAC and water systems performance through data-driven retrofit strategies, enabling measurable energy and carbon reductions. She has an MBA and PMP certification. She brings a systems thinking approach to solving complex challenges and is passionate about empowering organizations to accelerate their transition to net zero and sustainable operations. We also have Sophie Thomas, who's a senior sales specialist at Grundfos. They work closely with engineers and consultants to drive specification success in pump solutions through technical expertise and product training. They have a focus on HVAC energy optimization, helping to improve system efficiency and performance with the right pumping strategies. They bring a strong customer-focused approach to enabling informed design decision, and they're passionate about supporting sustainable, high-efficiency building operations. A special note and congratulations to Nitesh for winning the Energy Engineer for 2026 for the Canadian region for the AEE. Now I'll hand it over to them, who will talk us through what Grundfos does and energy optimization in pump.
Good afternoon, everybody, and welcome to the webinar. Thank you for AEGTA for giving us this opportunity to present energy optimization as a concept and the products involved to this audience. I will be turning my camera off because it just helps me concentrate. We will also be taking questions towards the end of the webinar, and in case we do not have the time to take the questions in this forum, we would really encourage everybody to write to us directly or write to AEGTA, and they can redirect the questions to us. So yeah, again, welcome everyone. My name is Nitesh. I've been introduced already, so I won't waste time on that. Yeah, so energy optimization is something that is really close to our heart, and let's begin. So this is going to be our brief agenda. We'll be talking about energy optimization by Grundfos, and there will be several heads that we will be talking about under the topic. Then I will hand it over to Sohail, who will be talking to you about the products and concepts that make EO possible here at Grundfos. We'll be talking very briefly about the Quick Ship program, which is our recent highlight, and then we'll open for questions and answers. So let's just introduce Grundfos first. So Grundfos is a company that was founded in 1945, right after the World War was over. And we are a company that is focused on pioneering solutions to the world's water and climate changes. We are really focused on improving the life for people around the world. And we are also one of the first companies who has our own net zero target at a global level. We really believe that water has the power to change the world, which is something that we really take seriously and take it to our heart. To add to this, by 2024, we have reached 93% of our 2025. By 2024, we had reached 93% of our 2025 target to reduce water withdrawal in our own operations by 50%. Compared to the 2008 baseline year. We also enable efficient water and wastewater management. We believe in optimizing water treatment and water reuse. And we also act towards providing safe water access to thousands of families in underprivileged conditions. This is something that drives us day in and day out, where others see problems, we see possibilities. And this is what has really been at the core of our innovation throughout the company and at a global level. So the whole story of Paul Dujensen coming to US and how the business began in North America, I will leave it to Sohail to talk about towards his presentation. But and believe me, keep your ears open because it's an interesting story. We are one of the world's leading pump and water solution companies. We are 20,000 plus strong employees, stronger company. 87.9% of this is owned by Paul Dew Jensen Foundation. So yes, we are not publicly listed, and this enables us to put our 5.8% of revenue to be reinvested towards R&D solutions. And that is what really enables us to drive that innovation that we all strive to achieve. We produce over 15 million pumps every year, generating a revenue of 4.5 billion euros. Yes, innovation drives us forward. We cannot emphasize on it enough. And this is driven by our 6 values that we strive to be sustainable. We believe in being open and trustworthy. We are focused on people, an independent company. As I mentioned that we are not listed, so we're not answerable to shareholders. We believe in partnerships across the board, right from vendors to customers to the end users, and we are relentlessly ambitious. Yes. So these are our 6 values that keep us focused and keep us going. We think globally and act locally. Yes, we are present in over 60 countries with over 100 companies across the globe. Each of the companies has their local policies driven by the global policies that are in place. Grundfos works under 5 different business units: water treatment solutions, commercial buildings, industry, municipal or water utility, and domestic buildings. So Sohail and we belong to commercial building services, and that is why we are here talking about energy optimization in commercial buildings with you today. So this was a bit about Grundfos. Now coming to energy optimization. To introduce the concept, I hope everybody has heard about the concept at one point in time or the other, because this is something that is the need of the hour. This is how we define energy optimization in Grundfos, using the energy in the built environment to maximize benefits for the climate and for people. And you will see how we took this as the baseline, and we have tried to improve upon this definition. When I normally speak about this definition and ask people if they have something to add to this, I do not get a lot of responses where people disagree with this statement. But since there's always improvement possible, I think we have done a little better to modify this and modify the concept. Why EO in pumps? Like I'll be calling energy optimization as EO. So yeah, why EO in pumps? Why should somebody look at those little equipment in the mechanical rooms and think that, yes, this equipment can be important, or this equipment really needs innovation, or this equipment can really add value to my business if I look at it closely and try and replace it with something better or apply some new concept to it? Let me present some facts. So, did you know that 10% of the worldwide energy consumption comes from pumps? And if we translate it into a dollar value, the total energy consumption of the world in 2025 was 30,000 plus terawatt hours. Consumption by pumps, by this definition, comes to 3,000 terawatt hours. So the total cost of electricity spent in running the pumps was $510 trillion. Do we really think that we cannot really do better in improving this figure? The next fact, 40% of the energy in properties is used by HVAC systems. This can go from anywhere between 30% to 70, 75% in some cases, depending on the application. So another reason why we should look at the pumps, because HVAC systems are majorly supported by pumps in different applications. 2 out of 3 pumps use up to 60% too much energy. And this is attributed to different factors: age of the pumps, capacity of the pumps, number of backups in place, how the operations are running, etc., etc. What kind of automation is involved? Yeah. Unplanned downtime can lead to up to 30% more costs. Which one of us has never seen a scenario in the field where a building heating system is not compromised because a pump has stopped running? We have all seen that. So yes, and in those scenarios, there is a lot of band-aid solutions that are available in the market, but yes, all of them cost a lot more than it would have to just maintain that pump. And not the and the last one, availability of spare parts for pumps older than 10 years becomes critical because the pump has a life cycle, and we should really be talking about maintaining the pump, monitoring the pump, and keeping the backups in form of spare parts and in form of backup pumps. So talking about all of these facts, this brings us to the challenge that commercial buildings face nowadays. These are the major challenges that are faced by commercial buildings. Buildings are the major consumers of water and energy. Up to 50% of the total energy consumed is consumed by commercial buildings. As the world urbanizes, the demand for high performance sustainable buildings is more critical than ever, because we cannot be just paying through our teeth to maintain the building or to sustain the building or to sustain the operations. We understand the customer's commitment and customers' commitment to reduce their environmental footprint and enhance property value through smart green initiatives. So this is something that we are committed to. And to present some amazing figures from IEA and NRC and Efficiency Canada. You see those right there on the screen. I'll just read through those quickly. Commercial and residential buildings account for 27% of Canada's total energy demand. And these are just the commercial buildings where the businesses are happening. This does not even take into account the adjacent buildings which are involved in operations of those. Over 75% of the buildings that will be in use in 2050 have already been built. And this is why it is so important to look at the retrofit in different equipment in any of the buildings. The annual retrofit rate in Canada is less than 1%, while a 3% rate is needed to meet net zero targets. So we are lagging 60% behind in the activity that needs to happen to make any of the buildings energy efficient. Now let's see what an average commercial building and the consumption in the building looks like. This is how the water consumption in an average commercial building is throughout the day. And this has been taken from an actual pump audit in the field. So you can believe me when I say that the consumption is really low in the morning hours, and it's really high towards the evening when the people are ending their day. So, and I'm sure everybody has seen these trends in the field, and they have dealt with these trends in the field. On the y-axis here, we have shown the flow, and on the x-axis, we have shown the time of the day, just to bring it in context. So looking at it, there are several ways that we can size the pump, and we can understand we can meet the demand in the building actually. So this is the bare minimum that the building needs to operate at any given point in time. And this is the maximum need of the building that can happen during a day or during any given period of time, actually. So which one would we be more inclined to size the pumps for? And this happens for most of the equipment, actually. But yeah, let's talk about pumps. So which way are we inclined to size the equipment? To meet the minimum demand or meet the maximum demand that is ever possible? The answer typically is that yes, we should be sizing the equipment based on the most of the demand, that's the highest demand that's possible in the building. talking, like keep this in mind, and we will move to the life cycle cost of the pump, and then we will see how things go. So all of this talks about basically the operation of the pump that is needed in the building. And this is how the life cycle cost of the pump looks based on how we have selected it, or any pump rather. So only 5% of the cost goes into the purchasing price of the pump. So that is our capital expenditure when you're thinking of buying a pump or investing in a pump in any commercial application. 10% are the maintenance costs, and life cycle can be anywhere between 10 to 15 years or even 20 years at times. 85% of all that money goes into the energy costs that the pump is consuming. So again, think about those lines A and B. Where would we want to keep our selections in order to meet all of the demands of the buildings? So looking at this is our inspiration to actually talk about energy optimization, developing the concept and market it as an aftermarket product or as a retrofit um, product, and come up with something better. These are the Grundfos's energy tools that are part of our energy optimization portfolio. Based on the visual and physical investment that is needed, and based on the level of efficiency potential that we can suggest in the solutions that we come up with, we have plotted the products on this graph. Replacement is something that can happen one-to-one. If the client insists, we can simply provide the pump of the capacity that they need it for. Then comes booster check and energy check. These are the solutions that involve some level of visual and physical investment in terms of people visiting the site. Efficiency potential is higher because we have actually collected the conditions from the site as to what the pump is, where the building is located, what kind of application it is in, etc., etc. Then comes energy check advanced. This is where we monitor a bit more parameters and we try to take the information from the building BMS. It can be done with a small sensor that is installed right at the site. And this, of course, is higher in investment because there's a sensor involved that we have to install. Then comes the energy audit, which is highest in the investment because we have to send our people out, install the equipment there, monitor the conditions, the flow, the energy consumption for up to 2 weeks, depending on the application again. So we monitor the equipment for up to 2 weeks and bring that data back to analyze and give the client the right selections. So again, since we have a lot of information and a lot of visibility of what is actually happening on the site or in the building, the efficiency potential of the solutions that we propose is the highest in this case. However, looking at the speed and the number of visits that can be done and the accuracy of the process, we insist on going towards booster check and energy check. Booster check, as the name suggests, is for the booster pumps in any commercial building, and energy check is for all of the other hydronic pumps that exist in a building, and this can involve wastewater pumps as well. So again, we visit the building, we collect the information on the site, and we bring it back to analyze further. To summarize the whole process of how the energy optimization process works, this is a concise snapshot of what happens right from when the inquiry lands with us to the recommendations that happen to the customer. So we collect these information from the site, the design parameters, like what the pump was actually designed for, the pump information, what pump it is, and operational information based on how it is done, if there's any automation, if there's a backup pump, or if there are multiple pumps, then which pump runs for how long, etc., etc. Based on this, we do the recommendation. We make the recommendations to the customer. So in the recommendations, yes, pump selections, of course, the best pumps that we think would be applicable for this for any given application. The energy savings that will happen if the said solution is installed, the carbon dioxide emission savings that will happen because of the new equipment again, and the applicable incentives, if there are any, depending on where it is being installed. Like IESO and Save on Energy have quite some. I'll be talking about that later on. Based on this, the resulting savings that happen at the clients or at the end users operations are in the operational costs, the maintenance costs, and the life cycle costs of the whole pump, basically. Based on that, there's a payback period that is indicated in the report that I will be showing you in a minute. I would want to highlight here that when we do the booster check and we make the recommendations, a lot of the times this is a resizing of the pump that we do. We do not encourage like-to-like solutions for booster pumps, especially because a lot of the pumps are oversized in the field. And so he will be talking about that as well. So you will see that happen. For the hydronic pumps or pumps in anywhere in the HVAC loop and not in the boosting application, we do not usually resize the pumps. It is a like-to-like replacement, but we give you the best solution that would apply and that would save a lot of energy. Saying that, we very carefully use the term resizing because there have been times when we have suggested a higher capacity pump to the customer based on the needs. This is what our information collection form for booster check looks like. We have quite some information here that we collect from the site, or we ask our partners to collect for us and provide to us to do the analysis. This is our energy check information collection form, which has quite some detailed information that we need to collect, and then the data is analyzed. These are the sample reports that we submit to the customer at the end of the analysis. So this is the one for booster check, where we have indicated the annual energy savings, the recommendations, everything, and the incentive value that would be subject to approval from the right authority. This is the reporting energy check, report for energy check that happens. We propose the number of pumps that we assessed. We also propose the number of pumps with energy savings potential. This number can differ. There might be times when we find that the solution that is installed on the site is the best possible solution that is there, and we will not even touch that. So you can be very sure of getting the right solution from us. And we are not really focused on how much we can sell to you. Going on the impact of this, I have a couple of case studies. This is an educational institution in Toronto, which had 3 buildings, and it had 20 plus floors of student residences and commercial units. The original configuration of the boosters over here was 3 into 15 horsepower, 2 into 20 horsepower, and 20 into 50 horsepower, respectively. When we were done with our analysis, and we did our selections based on the cases that we have collected from the field and which comprises our model for selection, we suggested the customer to install 4 into 5 HP of pumps, 22 and a half horsepower in second building, and 60 horsepower into the third building. So the total horsepower was reduced from 185 horsepower to 102.5. So this is the kind of reduction that was possible, and we did it for the customer, and the buildings have been running fine ever since. There has been no complaints on water requirements. In addition to that, this is what the customer reaped from installing the newer solution. The estimated energy savings were close to 500,000 kilowatt per year. $70,000 of savings in operation expenses every year. So this is basically money back in the pocket. 66 tons of carbon dioxide, carbon dioxide every year was not generated. Payback period for the whole project was 2.2 years. And in addition to all of that, the customer got 46,000 of incentives from the Ontario government. So the added value to the customer in terms of the equipment was that it's a plug-and-play system, pretty easy to install. You don't have to keep the buildings without water for days at length. We have an advanced control interface that we'll be talking about later on, and the connectivity with the BMS so that the pumps can be controlled right from the BMS room. Another case study that we have here is with a rental buildings company. We replaced boosters in 16 rental buildings for this single client. The total number of units that were affected were 2,000 in here. The total HP installed was 212, which we brought down to 158. So in here, there were multiple configurations, and there were times when we actually upsized the system because of the building needs and the complaints that the customer was facing. In this scenario, 91,000 was doled out as incentives. 1,000,000 kilowatt a year was saved. That was 89% of savings in energy consumption. So remember that 85%, that was brought down by 89%. $137,000 was saved in operations, and payback period was just 2.8 years on an average. The customer got much advanced solution. It was plug and play, quick installation, etc. So here, one word was very emphasized upon by me, and it becomes a great factor, which is the incentives. So in Ontario, and this is only for Ontario, I am not sure how many people from out of the province are here in this webinar. So these are the organizations that are involved in giving out the incentives and doing the evaluation for the incentives for any given client. We deal directly with Save on Energy. Like, we have our own app rep account with them, and we file the applications for the clients. We front end it with the Save on Energy, and we keep ourselves abreast of all of the IESO developments that happen, and they roll out the new programs and new policies. The last major development that happened was in October of 2023 especially for prescriptive scheme. So this is how the incentives look like if we install the right solution, and it just comes as an added advantage to the customer. 1,200 per horsepower for boosters, up to 3,000 per pump for the ECMs that are replaced, and there are double incentives for certain regions depending on where the application is being installed. The incentive application process with us is this. So it is pretty much guided by IESO and Save on Energy program. So all of this information you can also get from Save on Energy's site. Yeah, so we only facilitate this program. This process. We are not the actual applicants. We let the customer, the customer is the applicant, and we only create the applications and front end with Save on Energy to ensure that the process is smooth. So the Grundfos value add in all of the energy optimization program is that we have a dedicated energy optimization team. We are a team of 14 people sitting across the globe doing the analysis and enriching our development model by collecting information from the buildings that we do on daily basis. By now, we have over 10,000 buildings data from across the world and more than 1,500 buildings from Canada alone. So that helps us refine our model. We recommend what's needed. We do not go by the sales figure, but we go by what the clients really need. The incentive amounts are indicated right in our energy check and booster check reports. It is clearly mentioned that it is subject to IESO approval. The base cases have been worked and developed with IESO in the past, and we always are there to provide any technical clarification or any calculations that IESO or Save on Energy asks of us. There are service and digital products that Grundfos has an offer, and we can do a separate separate presentation on it sometime. Or if you are interested, we can definitely you can reach out to us and we can talk about it. There's an app that is there to do the booster checks right on site, and we can really make the process quick. So based on all of that, the first line that I mentioned, that how we define energy optimization, we have refined it to this sentence that says using only the absolutely needed energy in the built environment to maximize benefits for the climate and for people. So we really believe in using exactly what's needed and not a kilowatt hour more. So thank you so much. This is all about energy optimization, and I'll hand it over to Sohil now, who can talk about the products that make it happen. Sohil, over to you.
Thank you, Nitesh. I'm audible, right? Just wanted to make sure.
Yes.
Okay. Welcome, everyone. Thanks, Nitesh, for the presentation, and I'll take over the second part, which would be mostly on energy optimization and what kind of products are making it possible within Grundfos. So I'll share my screen. Just let me know if you're able to see it. You're able to see the screen?
Yes, it's not in the presentation mode though.
Yeah, I'm changing it. It's visible now, right?
Yes.
Okay, so I'll also be off camera to just focus on the presentation, and we'll take it forward. Okay, so my first slide is, I always like to start with a story on how Grundfos started. The person that you see on your screen is Paul Du Jensen, who's the founder of Grundfos. He started his business in that small house, basement of his house in 1945. How it all started, once a local farmer came to him to repair a pump because he was a machinist by trade. But when he looked at the pump, he said that that is not repairable, but instead he can make him a new pump. And that's what you see on the screen. What it was a pump that he made for the farmer, and it was a success for him. So seeing that, he actually tried building a couple more, and it sold like cupcakes. So seeing that, he understood that this is machinist was not his cup of tea. Instead, he wanted to just start a company in his small house that you can see, and the rest was history. So today we are in more than 60 countries, manufacturing almost around 70,000 pumps a day. And we are proud to say that we are one of the biggest, not one, but we are the biggest manufacturer of pumps in the world. So that's a small story which I always like to share, which is always an inspiration for many people who dream of starting a company and becoming one of the biggest manufacturer in the world. With that said, I'll come to my next slide, which would be a quote from ASPE. As you can see, the single biggest threat to energy efficiency is always over-design. What that means is everybody thinks that energy waste comes from the old equipment. But in reality, even ASPE has identified that the biggest threat is always to pump efficiency is basically the over-design. So in a way to put it, even a well-maintained pump can waste a lot of energy because it's actually producing more flow of pressure as compared to what the actual building needs. So it's always important to actually right-size the pumps, and we'll come across some examples which could actually prove what that is going to be. With that, I'd like to share a small video which says why correct pump sizing matters. Just let me know if you're unable to hear the voice too.
Pumps are responsible for 10%.
Can everybody hear the voice? Nitesh, can you hear the voice?
Of the world's electricity consumption. This staggering number is mainly due to the many inefficient pumps that are either worn or wrongly sized, resulting in an excessive waste of energy. In this short module, we're going to introduce you to energy optimization and its benefits. Simply put, the waste of energy from pumps is the most obvious sign that energy optimization is essential to not only save energy, but also reduce the global environmental footprint. In fact, studies show that the average potential savings per pump amounts to 15,725 kilowatt hours. That is the equivalent of 1,570 euros per pump. To put it into greater perspective, this number equals the yearly CO2 emission of 3 cars. Optimizing your pumps can have a great effect on the environment, but it will also save you tons of money. Let's take a closer look. As we mentioned at the start, wrongly sized pumps are one of the main sinners in terms of pump inefficiency. But why are they wrongly sized in the first place? Some design engineers include a safety margin when designing pumps to compensate for uncertainties in the design process. However, if a pump is wrongly sized, it will add to system costs, both in terms of energy and maintenance, which brings us to the next point. Over the course of your pump's life, energy costs account for a massive 85% of the total costs, and service and maintenance costs account for 10%. So while a wrongly sized pump may provide a safety margin, it also means that the pump won't perform optimally, and that will have a massive impact on your energy bills. To sum up, there are 2 major takeaways when it comes to energy optimization. First of all, optimizing your pumps slashes your energy bills, saving you tons of money. And secondly, by energy optimizing your pumps, you reduce your environmental footprint, an important step in the fight against climate changes. Pumps.
With that being said, I'd like to just go through a bit of a history here where we have been using Hunter's curve to actually identify what the max peak limits for different buildings depending upon the fixtures. But as time evolves, as you can see below, earlier it was around 5 gallons per flush that we used to use. It has reduced to 3.5 in 1990, and you see in 2012, it has even reduced to 1.28, which is a drastic reduce from what we saw 20 years before. So in a way to put it, this is basically because we have advanced technologies, low flow fixtures that's been mandated in new buildings, and that has brought up to this level of reduction in actual consumption. So what Grundfos has done to cater to this is basically we have started the energy optimization program in Canada, where we identify what the load profiles and the flow profiles for different buildings are, and we use those database to actually right size the pumps to engineers, consultants, and whoever wants to retrofit different boosters when it comes to those kind of sizings. And also, as you can see, the water demand calculator from IAPMO is also added to Uniform Plumbing Code. As you can see in 2018, that was also introduced, which is actually helping the engineers to actually size it better as compared to what we were doing a couple of years before. Now, a little information on what efficiency looks like and what all parameters that we have as far as pump is concerned. From the slide, you can understand that the overall efficiency is a combination of both the motor and the pump efficiency. So all the electrical input that is being provided to the motor is not being converted into hydraulic power. So as you can see over here, the efficiency of the pump alone was close to around 62.3, whereas when you clubbed that motor along with the pump, it dropped down to 47.5. So we need to make sure pumps are actually working at the best efficient point to make sure that the energy is also consumed at the lowest level. You can see the efficiency curve here, which I want you to actually remember how this curve went up and it dropped down as it goes towards the far right end of the curve. So that's a snapshot of what this looks like, and a small a pump curve, what you can see on the screen. We always want to actually run the pumps on the best efficiency point over here, but that's not the case what you see in normal conditions. You won't be able to run those pumps continuously at the best efficiency point. But the main aim is to run close to that so that the efficiency is the highest and the vibration would be the lowest as well at that point. So the main goal is to operate around that region so that we get maximum reliability for the pump, and the energy savings is also at the highest level. Also, you can see this dotted line over here, where when you see if the flow is actually going less than this, there is a minimum continuous stable flow what every pump needs. And if it goes less than that, there is a thermal flow that's going to create, which is going to create cavitation effect throughout the pump, and that's going to damage the impellers and other components that's within the pump systems. So the main idea is to operate it around the BEP and what it takes to make sure that we operate around that region and within the rated or the preferred region that you see from the screen. So this is some of the case studies from which Nitesh was actually talking about. I'm taking the second one here for an example. This is a couple of the audits that we have done in various buildings around GTA and Canada, where you can see this was a building where it was designed for actually 700 gallons, if you see. But when we looked at the actual load profile, what we see is that pump is not pumping more than 106 gallons. That's the peak flow. And that too, you see only around 2% of the total pump running time is where this peak load is operating. So if you see where the actual pump working is happening, this 60 to 80% is happening even less than 10% of the actual design flow that was designed for. So what happens, as you saw in my last slide, it would actually run towards the left-hand side of the curve, go below that minimum continuous stable flow, and that creates that thermal flow issues, and the reliability, the efficiency, the power demands, everything is going to affect the pumping systems if they are not right-sized. So that's why this is very important to size the pumps at the right point. And in order to do that, what we have is called as we have a system in place to cater to those kind of part load conditions, because you obviously need to take care of the part load as well as the peak load too. So you need to size it based on the peak load, but in order to have the reliability to go for the part load conditions at highest efficiency, that's where these things come into picture. If you see from the screen, what you see as green would be where the majority of the time, which is 18 to 20 hours throughout the day, where the pump is operating, which is part load. So the actual flow is actually less than 20% of the design flow, and that is running 70 to 80% of the time. So that is why we actually have to make sure that we need a multi-pump controller. Why do we have this system in place? So this is a Hydro MPC multi-pump controller configuration where this comes pre-wired, pre-tested from the factory, and with an advanced Genicon controller that comes with it. This is a NSF61 372 approved system, and you can go from 2 to 6 identical CME or CRE systems. It comes with SS316 manifolds, comes as a complete package system where you can just install this, and the contractor sees it, finds it very easy to actually install and commission at site. So you're saving a lot on time, and at the same time, you're getting a complete system from Grundfos, which is highly efficient, highly less energy consumption as well. With that, we'll just go towards a little bit on the motors as well, what we use. In Canada, the minimum requirement on efficiency level is NEMA Premium, which is equivalent to international code IE3. But as you can see, what Grundfos offers is at least 2 levels up, which is called as a Grundfos MLE motor, which gives you IE5 efficiency level, which gives you at least 7 to 10% additional energy savings at nominal load. And if we look at the screen, you can see that at full loads at 1800, the difference might be a bit less, but still you see that difference over here from 92% to 95%. But at nominal loads, which we see, which is majority of the time the pumps would be operating at part loads, that's where this becomes highly efficient, where you can see that it runs at 86% efficiency with NEMA Premium, whereas Grundfos motors goes to about 92% efficiency. So that's why it's always important to make sure that we have the highest efficient motor that's available in the market to make sure you get the most amount of savings when you go for it. Now let's come to a little bit about the pump controls as well that we have, which is called as the Genicon controller. We had another controller which was called a CU352, and that was replaced by Genicon controller in the AHR show this February back in Las Vegas. So what these controllers does is basically two things. One is to save that energy. It size the staging is basically done based on the efficiency. If you see traditional systems with PLC based systems, what it does is if you have a VFD, it would basically run based on the speed. So let's suppose the first pump reaches to 90% speed, and if the demand is more than that, then the next pump kicks in. So what it does not take care is actually the efficiency, and it's not running at the highest efficiency point. But instead of that, what our controller does is we actually load all our efficiency and the pump curves into the system. And what it actually does is it does the calculation and makes sure that pumps are running at the highest efficiency based staging. So what that means is, let's suppose there is a requirement for 100 gallons per minute to be run. And if the system calculates and see that it is better to run 2 pumps at 60% speed than running 1 pump at 90% speed, it opts that option to make sure the energy is less as energy is consumed, and at the same time you're not compromising on the efficiency as well. And at the same time, you also know that as you can see over here, I'll skip this slide. As you know, efficiency over time is definitely going to diminish. And that's because these are all mechanical components. You will have wear and tear over a period of time, let's suppose 10 years. And you know that this is going to drop because the hydraulic efficiency is going to definitely come down after a point of time. So in order to cater to that, what do we have is called as a power optimal pump sequencing, which actually looks into the current situation of the system. It identifies which is best, which would be the best scenario in terms of power demand, and stages the pumps accordingly based on power. So this is some feature what we have inbuilt in our systems too, to make sure that the efficiency is not compromised, and at the same time it's running at much less energy consumption as well. We were talking about plumbing, but this goes to the HVAC situations too, because we see the same thing around the HVAC systems. This is a typical, chiller application where you see that more than 90% of the time, the system is operating at less than 75% capacity. But what do we do usually? We size the pumps to run at best efficiency point at 100% load. But what's actually happening, it's running at part load conditions, and you're not getting the best efficiency, more energy consumed for those kind of applications. That's why we have the same applications available for HVAC systems too, which is called as the Delta HCU, which is called as Delta Heating Cooling Unit, where a similar package system like what we saw for Hydro MPC for plumbing, we use this for heating applications. Again, this comes as a complete package system, complete with discharge and suction manifolds, integrated drives, controllers, isolation valves, manifolds, and it comes as a complete package system from Grundfos, pre-wired, pre-factory, tested, and it's smooth for installation for the contractors too. So why do we choose this? It's basically because of the 3 boxes that you see below. It saves time, saves money with easier installation, and it saves a lot of energy because the controller is actually doing the job for you, maintaining the highest efficiency at all levels. With that, I'd like to just introduce a small concept that we have in our portfolio too, which is called as distributed pumping system, which makes it easy to balance the chilled water systems and enhancing the comfort in buildings. So the solution basically replaces the traditional balancing and control valves with intelligent pumps that you can see over here, which is the Magna pumps. And this basically improves the overall delta T and reduces the energy in commercial buildings. I'd like to show a very small video about the distributed pumping and how this is made to happen. And we'll quickly go through that video before ending this.
There are many considerations when designing a cooling system for commercial buildings. To cool a building, existing chilled water systems generally use large centralized pumps and chillers in the mechanical room for pushing water around the chilled water loops. Regulating the flow due to the varying cooling needs is traditionally done using balancing and control valves, typically located close to the terminal units. But even efficient valves consume unnecessary energy due to pressure losses. Furthermore, a bypass line is typically used in the system to ensure sufficient flow to the chillers. Cooling systems with central pumps and valves have been designed in this way for decades. However, there are issues shared by existing cooling systems that lead to high energy consumption and less comfort in the building. One is commissioning and balancing, which is traditionally a time-consuming and tedious procedure, but essential for ensuring a system that operates to its highest potential. Inadequate commissioning leads to poorly balanced systems and excessive energy use. An incorrectly balanced system will result in having terminal units receiving more or less flow than necessary. This could also lead to low delta T. This is especially apparent at part load conditions and results in less comfort. But what if we design the system in a better way? Our solution is Grundfos distributed pumping. By replacing valves with intelligent pumps, we use less energy while bringing more intelligence to your cooling system. A Grundfos distributed pumping system uses the maintenance-free Magna 3 circulator and low-pressure non-return valves to prevent backflow. The distributed pumps ensure optimum pressure and flow at each terminal unit at all times. This also allows the centralized pumps managed by a new control logic to be significantly downsized because of the distributed pumps. This new design delivers perfect cooling comfort when and where it is needed within the building. With Grundfos distributed pumping, you achieve the following benefits: an automatically balanced system at any load, significant energy savings, easy and fast commissioning. Let us help you design an efficient and reliable system with our knowledge and advanced tools. Cool your building more intelligently with less energy. Grundfos distributed pumping.
I'll finish my slides pretty quick. I think we are almost close to end of our session. So this is the pump that makes it available to go with the distributed pumping concept, which is the smartest circulator that's available in the market. This is a ECM circulator. It uses a delta P and a temperature sensor that's going to make it highly efficient. And this is also a wet rotor circulator, meaning actually we allow some fluid to actually go through the rotor can that you can see here to cool the top and lower bearings and to make sure that it becomes maintenance free throughout its entire process. So in this way, you are actually eliminating the PIC valves, the pressure independent control valves that you usually use for balancing purposes in these kind of systems. And this system automatically gets balanced by using these kind of pumps. So one other feature is a flow limit function as well, where you can actually limit the total flow that's going to go through the system in order to avoid overpumping as well. Where you can see previous old situations would be putting a control valve to actually limit the flow. You're actually eliminating that, reducing the cost on that. We are electronically asking the pumps to reduce the overall flow that's going through the system. So in this way, this is a cool feature which you can actually utilize in maybe domestic hot water recirc applications as well, in order to avoid any erosion purposes too. So this can be wirelessly communicated between each other. They communicate through radio signals via Bluetooth too, and you can actually connect it to the Grundfos Go app, which is making it possible to actually put it in cascade mode, alternating, or even backup mode. This is a live demo which we have in our Oakville location. If any of you wanted to actually go through this, having a live demo in our facility, we are more than happy to welcome you to actually show this, how this works. works. You can see the Delta units here. You can see the Magna pumps serving different fan coil units and air handling units, which you can actually be visible in as a complete working demo in our facility. One small case study about this, we were able to do this in the Museum of Flight back in Seattle, and a lot of savings have been recognized over there, and we are proud to actually introduce the system out there as well. With that, I'll finish my presentation, and sorry, it was slightly 2-3 minutes above time, and I'd like to see what questions do you have, or if you don't have, you can always reach out to me in the contacts that has been mentioned as well. Over to you.
Unfortunately, I don't think we'll have enough time for any questions, but if you do have them, please reach out directly to the speakers themselves. Their information is in the chat. So, thank you again, everyone, for attending. Just a quick word from us about membership to come along to events like this, or the ones that I introduced earlier on. Professional membership is $60 and students are $20. Now, I'll pause here just so you can look at the QR code, which you can follow onto our website and then sign up there. While I'm here, I just want to say thank you to Grundfos for coming along and for talking about their work. If any questions, again, please direct them directly to them, or you can go through us as well. Slides for this talk will come out later after this talk, as well as a certificate. If you've made it this far to the end, you should also see that as well. Again, thank you very much. Thank you for spending your lunch with us, and we look forward to seeing you at the next event or the next webinar. Thank you so much, and enjoy the rest of your day.